Afternoon, everyone. Thank you for coming to the 5 o'clock session here, scheduled right over the start of the dinner time. Somebody told me that the buses were running slow, so I figured some of you might have rather sat in here than wait in line for the bus. But my name's Tim McMichael. I am a senior support escalation engineer with Microsoft. I work out of our Charlotte support facility. And for about the last 12 years, I've had the opportunity to work in the cluster space. So started in the Exchange 5.5 with the NT4 option pack, for those of you that remember what those looked like back in the day, and have kind of moved on through. So today's session is going to be a little bit different, right? A lot of times when we talk about high availability and we talk about DAGs, we talk about things like the replication service and how does log shipping work and how does log truncation work and what is a DAG and all this other good stuff. But there's something that is critical to the functionality of the DAG, and that is how we leverage and use the cluster service that actually sits under it. So today we're going to kind of take a look at how it is we actually leverage and use that service in order to achieve a database availability group. So back in the day, Windows 2000, Exchange 2000, Exchange 2003, even Exchange 2007, whenever we leveraged the cluster service, we always had a cluster resource model. Okay? So we created this DLL called XRES. We would register it within the cluster service, and that's what lit up all these resources like the system attendant and the information store. And in Exchange 2007, when we had a database instance that sat on top of it, that's what made all those things possible. And it defined how we actually interacted with the cluster service. What was an isalive check? What happened when an isalive check actually failed, and things along that nature. Well, with Exchange 2010 and newer, continuing even through Exchange 2016, we've gotten rid of that. And I kind of point that out because I can remember when Exchange 2010 first hit the street, my first DAG crit set that came in, my first SEV-A, is I set up a DAG and there's nothing in cluster. Congratulations, you did it right. Right? There is absolutely not supposed to be anything in cluster. Okay? So if you open up Failover Cluster Manager and you see anything else in there that looks like an Exchange resource, you've done something wrong, right? Because there should not be anything in there. But nevertheless, even though we no longer have this clustered resource model, we are still heavily dependent on that service in order to be successful. Now, there's several things that we have not yet today been able to duplicate that we get from the cluster service, right? A method of actually heartbeating the nodes. So how do I tell that a node is alive, it's up and running, I can talk to it, that it's okay to have resources on that node? An interface for registry replication, in other words, a mechanism by which I can very quickly share data between the nodes in a DAG. The concept of quorum and how I actually maintain that across a series of nodes. A method to detect the network health between those nodes. And the cluster database itself to store our active manager states. And by the way, I like questions during the presentation, so if there's something just burning, feel free to just hop up and ask, and we'll be more than happy to talk about it. So when it comes to cluster heartbeats, what are we talking about here? The cluster heartbeat process is a way to determine whether or not a node or a subset of nodes is actually alive or not. Now, the method by which we pass information is UDP, on port 3343. Okay, so these nodes are constantly interchanging information with each other about their state and are looking for a response from the peers to see that they're still up and running. So it's a send and an acknowledgement. Okay? Now, we allow you to adjust heartbeat tolerances, and this is something that came with Windows 2008, has kind of evolved a little bit. You know, for those that used to have a cluster on Windows 2003, Windows 2003 was very intolerant to heartbeat problems. I would send a packet, and if I didn't get a response, the node was considered dead, and it went away. Right? So it was once and done. You had very little flexibility. It also meant that you could not grow the solution to different geographic locations, especially those geographic locations where there might be questionable network links between those nodes. So in 2008 and 2008 R2 all the way through 2012, we've kind of taken an approach to relaxing the way we look at heartbeats and the method by which we determine whether or not a node is up or down. So you can see here in this table, there's two things that we talk about here. We talk about a delay and a threshold. Okay? So the delay says, how much time do I wait before I consider the heartbeat that I just sent to be unacknowledged? Okay? And then the threshold says, how many consecutive node responses will I wait for before I consider the target to actually be dead or unresponsive? Okay? We break these out into same subnet and cross subnet. Now, the reason we do this is we assume that if you are geographically dispersing the nodes within the solution, that those nodes are going to reside in different subnets. Therefore, we allow you to change the way you want heart beating to work in that cross subnet versus two nodes that reside in the same subnet, which are assumed to be geographically located with one another. And you can see here in this table, right, we've got what we call fast failover, which is default. So right out of the box, we're saying cross subnet, we're going to consider a heartbeat dead at 1 second, and we're going to consider 5 consecutive heartbeats of no response. The entire node is dead. We have something called relaxed, and this came from, by the way, this table came directly from a blog by Eldon Christensen from the Windows team. If you haven't seen it, I don't have a link to it in here, but it's pretty easily found online. He goes through a great explanation of why this table was created in this manner and exactly what their kind of take on these values are. But you can see here with the relaxed, what we're saying here is we're saying we're still going to continue a heartbeat to be dead at 1 second, but you're going to have 20 consecutive failures in order to mark that node completely and totally down. And then you have the maximum values. So the maximum values for 2012 and newer, cross subnet 4 seconds up to 120 heartbeats, and then for same subnet 2 and again 120 heartbeats. Now, what's interesting here, and it's really important to realize, anytime you change these values, you are adjusting the response to failure. So if you take the threshold and you multiply it by the delay, that's going to give you the amount of maximum time it's going to take to figure out that a node is actually dead. Okay, that a node is down and a node is unresponsive. Now, does anybody know what the biggest issue with these values are overall, though? The biggest issue with changing these values. It's not just the amount of time it takes to find a node that's dead. Huh? Not necessarily. We're not really worried about maintenance in this case, right? Anybody else want to venture a guess? Huh? Nope, not quorum. The biggest problem is that we use these as a stopgap for networking issues, right? So 9 times out of 10, how many people in here have seen an 1135? In other words, the dreaded my cluster service has terminated because it has lost connectivity with other nodes, right? If you haven't seen one, you're probably only a few days or weeks from one. They're actually probably the most prevalent error that you'll ever see across the cluster service, right? And what kills me is if you pick up your favorite browser and you you hit there and you say, cluster 1135, one of the first posts you're going to see is go out and turn these values up, right? Just turn them up. And the problem is that you've turned them up, and now your cluster service has successfully stopped failing, but what have you fixed? Nothing, right? At the end of the day, you have not really fixed what the underlying problem is, and you really haven't even taken the time to scratch the surface of what could legitimately be going on under the hood that is contributing to this. Now, 9 times out of 10, if you change these values and it fixes something, that is a clear indication that you've got something wrong in the networking layer, right? And that you need to be addressing that kind of problem. So this is not my first go-to when I get this. My first go-to is NetFT tracing with a good netmon and see if we can't figure out what is actually going on the wire. Now, there are just some circumstances that you cannot avoid, right? How many people in here have a WAN connection that is 90+% utilized on a daily basis? Right? These are candidates for most likely having to turn these values up no matter what. It's just a function of their network, right? Maybe new connectivity is coming, maybe new bandwidth is coming, maybe lower latency is coming. But for today, that's just the environment that they live in, right? So there are certain times where we just know environmentally that you're going to want to tune these values up. But I try not to use this as the first line prescription for things like the cluster service terminating because of incomplete membership or because it's lost connectivity with other nodes. And again, the biggest thing here on top of that is, the did we fix anything question, is the fact that every time you increment these values up, you are, in legitimate cases, preventing the cluster service from detecting the failure in a timely fashion. Right? The bigger this window, the longer it takes before we can actually realize a node is down and before we can actually respond to it. Now, one thing about these changes what's really nice is you can inject them with the cluster command. You can also inject them with PowerShell. So for those of you that are on newer platforms, PowerShell for cluster is very handy versus cluster.exe. But once you've injected them, they take immediate effect. No reboots are necessary. No restarts of the cluster service are necessary. Again, I cannot say this enough. Adjusting these values is not a replacement for doing due diligence in troubleshooting underlying issues, getting a handle on what the problems are and actually fixing those. And again, every time you touch one of these, you're skating that fine line, that balance between providing fast failover and making sure that you're offering network resiliency that you might be adjusting these values for. All right, registry replication. So the cluster members each store their own set of quorum data or their configuration data within the registry that is resident to each node. There's a process that lives inside the cluster service which is responsible for accepting updates to this information and transmitting that information to all the other nodes that exist in the process. We call it the GUM process, or Global Update Management. Now, any node that is successfully in a cluster or believes it's in a cluster has the HKey local machine cluster hive within the registry. Right? So anytime you see that key, you can be pretty assured that that node believes that it's in a cluster. So here's what it looks like. Nothing special to it. It just sits right here. And again, only time you should find that present is when the cluster service has actually been configured on a given node. Now, each node does have the ability to read and write to its local cluster hive, right? And the GUM update process is kind of interesting. I always think of it kind of like a token ring network. In other words, a node wants to take an update. It says to all the other nodes, I'd like the stick, I want to speak. All the other nodes say, we recognize node 2, and node 2 says, I've taken the following change. And then all the other nodes say, great, I've taken the same change too. And when we get that acknowledgement from a majority of nodes, we actually consider that to be persisted, right? Now, the one thing about registry replication in a cluster is that when it is working, because there's some cases where it doesn't, but when it is working, it is very efficient at transmitting changes quickly between the nodes. And that's one of the reasons we have chosen it to actually store exchange critical data that needs to be shared across the DAG members quickly, such that we wouldn't want to store it, for example, in Active Directory. Right? So for example, if I move a database from one node to another node, I want all nodes in the DAG to know about that immediately, so I'll record that to the cluster registry versus write it to the Active Directory. Especially in a geo-redundant solution where you've got nodes in 2 physical locations, if those are 2 different Active Directory sites, there could be anywhere from 15-minute latency all the way up to, I have a customer that has their AD site links set at 8 hours for cross-site replication. So it could take a while for the entire solution to know something's happened. You do not have that same problem when you leverage registry replication and the cluster service. So what do we store here? Right? There's 3 critical things that we store here. One is database state information, and we'll take a look at that here in a second. 2 is what the network communications between the nodes looks like from the DAG perspective. And 3 is our log generation information. So, under the cluster hive, under the Exchange Active Manager hive, we have the DB state key. So the DB state key is one entry per database that exists within the DAG. Okay? And what you see here, the name value right here, actually represents the GUID of the particular database that we're looking at. If you look at the data that's contained within that key, you'll see that it contains a few things we're interested in. So the active server indicates the server that the database should be active on. The last mounted on server tells us the server where that database was last active on or last mounted at. Now, one of the things that's interesting here is that if you were to, for example, issue a move, right? So you launch the Exchange Management Console, you said, I want to move a database from node 1 to node 2. One of the first things we do is we come into this key, this DB state key, and we change active on server to be the target of where that database is going to go, right? So anytime active server is not equal to last mounted on server, we know the database was in flight. It was in transit between 2 nodes. Now, one of the reasons we did that is, who coordinates all the actions in a DAG? Does anybody know what that process is? Well, more specifically, not just Active Manager, but the primary, the PAM, right? So we've got this PAM that's responsible for coordinating all the database actions across the DAG, right? So that PAM might be on node 1, right? So you issued your move, that move command was referred to the PAM starts its work, well then node 1 blue screens. So the PAM now arbitrates to node 2. So node 2, when it becomes the PAM, the replication service, and that server says, well, I need to go and I need to figure out, were there things going on that needed to be finished? For example, was there a database in flight? So one of the first things that happens anytime the PAM changes in a DAG is it starts to step through these DB state keys and say, do I find any databases where active server is not equal to last mounted on server? Yes, I do. Well, then I know I need to finish that mount information, or I need to finish that mount, and I need to update this key when that mount is done, right? And again, logging that to the cluster hive allows all these nodes to very quickly pick that information up and get it replicated between them. We also store the mount status of the database, whether it's currently mounted or currently dismounted for any reason. And an additional flag was added in 2010 for is admin dismounted. This is a flag that we set to true if you issue the dismount as the administrator. And essentially one of the reasons we set this is we know not to take automatic action against that database to mount it should the PAM be changing locations if you've actually selected to dismount it yourself. Now, the last log key. The last log key is what we actually use to store the last log generated on the active node. Now, in early builds of Exchange 2016, we only ever stored the decimal generation of that log file in this key. And later on, we added not only the generation of that log, but we also added the database GUID and the timestamp of when that log was created. Now, this is important because what we're actually doing here with this key is we're looking at the last log the active node generated, comparing it to the last log that was inspected on the passive copy, and that's how you get your copy queue. So when you do a get mailbox database copy status and you see that your copy queue is 100 logs, what that means is that we've looked at that last inspected and we saw it was 100. We looked at the last log generated, found that it was 200, and there's 100 logs left to be copied, right? Now, the database timestamp. What was interesting in early builds of 2010 was that it was possible that the cluster service just stopped taking updates, right? And when the cluster service stopped taking updates, we could no longer log to the cluster registry the version of the log or the number of the log being created on the active copy. So you might come along and you might run get mailbox database copy status, and it says your copy queue is 0, Meanwhile, your copy queue is actually 100 because we can't actually tell. Now, there's certain things. Windows 2008 R2 brought along some hot fixes which really helped deal with some cluster database locks. I still think there's some work to be done there moving forward because it unfortunately still happens every once in a while. But essentially what happens in that situation, one of the nodes grabbed the stick and refuses to let it go. So no other node can actually take an update or receive an update. But the interesting part of the behavior is none of the nodes actually fail out of cluster membership. They all still continue to heartbeat with one another. So the solution continues to work. We just can't really tell how far behind a particular node is. So what we said was, all right, here's what we're going to do. We're going to add the time into the last log key. So when we add the time into the last log key, the replication service on the passive node is now saying if I compare local time to this timestamp and it's greater than 12 minutes, then something is wrong, right? Because we generate logs at a fairly decent clip even when there's no user activity on the database. There's still database maintenance going on. There's still background checks going on. There's all these activities going on that do inject log records into the log stream. So we should see this value fairly regularly updated, definitely updated within 12 minutes. So does anybody know what happens when we find this is over 12 minutes? That's right. What's self-protection mode? Who said that? Fantastic. Here. Somebody read my blog. Throw that back there for my friend. All right, what is self-protection mode, since you know what that is? No, almost. I'm going to take that T-shirt back. Right, so self-protection mode has nothing to do with log file playdown, right? Self-protection mode is when we set the copy queue to max int 64. It's like 9 quintillion log files, right? So these are the crit sits that come into my desk that are like, my copy queue is 9.2 quintillion log files, and I have no idea what's going on. It's okay. You're really not that far behind. It's almost in theory impossible to be that far behind because you cannot have storage that is large enough to contain that many log files for a single database. Now, the interesting thing is that the solution to this is not as graceful as you might think it is. The solution is to reboot each node one by one until you find the one that actually holds the stick. And once you manage to kill the one that holds the stick, all of a sudden everything just comes back to life again, right? And sometimes it's really neat. You got a 16 node DAG, you get lucky, it's node 1. You picked it right out of the gate, you rebooted it. Sometimes you find it's node 16. Meanwhile, everything else is still down because the cluster service won't start after that. So you do this pretty quick, right? So you definitely don't take your time. Once you've committed to this, you keep going till you find it. So again, sometimes you can get lucky and you look like a hero. Everything's fixed in 30 seconds. Other times it's a half hour later, and everything's back up and running. But that's why we go into self-protection mode. Now, if left to its own devices, usually it'll just fall over on its own after a few hours, sometimes when you don't even know what happened at 2 o'clock in the morning. The other interesting thing about that particular scenario, too, is that most of the customers I've ever worked with that have experienced that will experience it one time and it never happens again. Right? It just is a kind of a fluke in terms of cluster database updating and the cluster database lock. All right. Moving on to some other information we store in the registry that's fun, our DAG networks. Okay? This is where we store all the information about the network communications paths that we have to ship log files between nodes. It's a big XML blob that's stored in a single key. And what you can see here is that our replication port is listed, whether or not we have encryption or compression enabled, and what subnets are associated with that particular DAG network. Now, this can be pretty long because sometimes you can have more than one DAG network depending on how you have everything configured. But every single NIC and every single subnet that you have that exists on a DAG node will be present in the DAG network's key. It must be represented, whether or not it does anything for Exchange. So, cluster networks. The cluster network, the cluster service, is responsible for looking at all the interfaces that exist across the nodes in a DAG and creating cluster networks that are associated with their particular subnet. So a cluster network is really an aggregation of individual interfaces that all belong in the same subnets. Now, the cluster service then takes those subnets, or those networks, and it builds a route table between all of them to determine how heartbeat information is going to be transmitted between those nodes. So this looks something like this, right? So if you open up Failover Cluster Manager, you'll see here under Networks that you've got your individual networks listed, and then here is the interfaces that reside within that particular network. Okay? Anytime you add a NIC and you add another subnet, then you will end up with a new cluster network created. And this is very important. One of the major misconfigurations I see come across my desk is customers try to take two interfaces and put them both in the same subnet. The cluster service does not deal well with that. Each interface that exists on a node in a DAG or in the cluster service itself has to be in a different subnet. Right? So I can't take two NICs, put them both in the mapping network and say 192.168.0.1 and 192.168.0.2. The cluster service does not deal well with that. Now in the Exchange world, the reason we hear about those customers, the reason we talk to those guys, is they call in and they say, I've got 10,000 DAG networks. One of them is full and 9,999 of them are empty. And that's because the cluster can't pick which interface it wants to use, and every time it switches, Exchange just says new network, new network, new network, new network, new network, and it just keeps creating them. And then when you look at that cluster key, it gets completely bloated with these empty DAG networks. And then again, the cluster interfaces, these networks that the cluster service defines, is what we pull into Exchange as the initial DAG network configuration. Now in Exchange 2010, a lot of customers would leave the default. So if I had, let's say I had 4 nodes, 2 in one site, 2 in the other. Let's say I had a primary network in site A and site B, and a secondary network in site A and site B. That would equal 4 cluster networks, which would subsequently be pulled into Exchange as 4 DAG networks. And in Exchange 2010, you had to go through and you had to say, okay, I shouldn't have 4 DAG networks, I should have 2. These 2 subnets can communicate with each other. These 2 subnets can communicate with each other. So now I'm telling Exchange that there is a direct relationship between those networks. Now, the problem with that is that a lot of people didn't read that section of TechNet. They completely missed it. And you really didn't know you ever had a problem because we don't let you shoot yourself in the foot. We still replicate log files. Unfortunately, we do it through one of the most inefficient methods possible. We query the DNS host name all the time when we're setting up our session instead of just knowing that these 2 IPs can talk to one another. So in Exchange 2013 and moving on to Exchange 2016, we said there's no reason for you to have to manually go do this. We can very easily figure out which subnets can communicate with each other. And that's where we came up with the concept of automatic DAG network configuration. So after Exchange sucks these subnets in from cluster, the replication service does a series of connectivity tests and tries to determine which subnets can actually talk to one another. Okay? And then it collapses those DAG networks into what should be the final topology. Now, this means that when you install your DAG, when you're getting ready to add your nodes to the DAG, you've got to have your networking set up, and you have to have it set up right. Common misconfigurations. I decide I'm going to have secondary interfaces, and I forget to put my static routes in, or I do it incorrectly. Well, now my secondary interfaces can't talk to one another. So when automatic network connection or automatic network detection kicks in, you end up with 3 DAG networks instead of 2. A lot of times we run into customers who have VLANs that are screwed up. And what I mean by that is that you've created this secondary network and you've tagged, the second NIC on node 1 to VLAN 7, and on the second node in the same data center, you tagged it on VLAN 8. Those 2 nodes can't talk to one another. Right? That completely throws off this process, as well as the cluster service. So it's really, really important that when you are laying out the foundation of these nodes, that you get your networks right. Now, how can we simplify this? How can we simplify this? Just use one network, right? I worked with a customer the other day that had almost 6 networks per DAG node, right? We had a network for public, we had a network for replication, we had a network for backup, we had a network for management. Then we had a network for 2 other things. I have no idea what they were. I couldn't even get that far, right? And when you look at it, it's like, what have we done in a solution like that? It's the C word, complexity, right? We've driven complexity up at little to no value to the overall solution, right? And I hear all the time, well, bandwidth shaping, and I want my logs to replicate here, and I want this to operate here, and stuff like that. How many people in the room have ever saturated a 1 gig NIC port? Really? With Exchange? Interesting. We were just talking about this yesterday. I was going through support cases when I was getting ready for this, and I have been unable to locate a single customer that has legitimately saturated a 1 gig NIC port between 2 DAG nodes, right? So when we look at it from a concept of support. Now, moving forward, 10 gig is starting to become very prevalent in the data center. Yes?
You didn't say that. You said never saturated a gig port. You didn't say
Well, here. Come on up here and get your T-shirt.
Thank you.
You're welcome. Hopefully it'll keep them quiet. I can move on. Anyway, so we're back to, right, in very few circumstances, we'll say very few instead of none, do we saturate a 1 gig NIC port? Now, with 10 gig becoming prevalent in the data center, right, especially on your newer servers where 10 gig is starting to become standard, and as customers are starting to adopt 10 gig backbones, it's becoming even harder to actually go through and saturate a NIC, right? So, I tend to, if you read my early blog posts on Exchange 2010, I kind of acknowledged, the fact that you might want to have redundant networks. One of the other big things that has really come to light over probably the last few months is the fact that when you read our documentation, you'll see that it says multiple networks are recommended but are not required. You're fully supported with 1 NIC. And everybody gets kind of hung up on that recommended piece of it. And what's interesting, too, is in the same document we say, you might want to have multiple networks because it helps you determine whether or not you have a network failure or a server failure. And I'm like, who cares? Right? Does it really mean anything to you to find out that the mapping NIC failed? Because guess what's going to happen? The databases are going to fail over. If the server blue screens, the databases are going to fail over. Net result, both the same. Who cares whether or not you knew right away that it was a network problem or a server problem, right? And then we go so far as to say, if your replication network fails, don't worry, we will shift replication over to the MAPI network. But we fail to tell you what a failure actually is, right? And this is the piece of it that kind of gets a little bit interesting, because let's say you go in and let's say you walk up to the WAN device between 2 data centers that control the replication network and you just turn it off. What do you think happens to replication between those 2 data centers? What? It stops. Your database is going to a disconnected state. And you're looking at it and you're going, well, wait, the replication network failed. Well, no, it didn't. Cluster still says it's alive. If I open up Cluster and I look at the NIC interface, it still says that interface is up. And that is the only thing we look at to determine whether or not a network is down. So unless you actually pulled the tap or you messed up your VLANs or something like that, Cluster always says the interface is up. So you end up in a situation sometimes where you've actually decreased availability rather than increased it by having multiple networks, especially for the purposes of replication. So you can cut your complexity and get more reliable results, most likely, by just going to a single network. Right? Now, how many people in here insist on having network teaming? Anybody? How many is it? It's just a standard. Everything has got to be teamed, right? Those are my favorite too, right? I talked to another customer the other day. They're on a 10 gig backbone, and they insist on having 4 10 gig NICs in a team. What are you going to do with 40 gig of bandwidth in Exchange? Right? Again, drive complexity up while offering little value to the solution. And when you talk to some of these guys, it's like, well, why do you have to have a NIC team? Well, if the NIC fails, I want it to fail over. Who cares? Let the database fail over to the other node, come fix it later. Right? NIC teaming is another one of those things that sometimes causes more issues than it actually fixes, especially when you fail to maintain your drivers, especially when you fail to maintain the NIC teaming software, and especially when you decide you're going to get away from things like load balancing, or sorry, fault tolerance. You're going to try to team for load balancing. But anyway, I digress. So the replication service, once it sucks these networks in, right, it actually creates the DAG networks, and then the settings of those DAG networks are what control the cluster network states, right? So we've got a DAG network state in the middle. We have a cluster network state on the end. So what you can see here is if it's mapping enabled true, replication's true or false, and the network is not ignored, the cluster is marked in cluster as use for both client and cluster communications. Client is a fancy way of saying there's going to be a virtual cluster IP bound to it, which will most likely in a DAG be the cluster IP address that you specified with the cluster name. So you've got mappy equals false, replication equals true, so you've established what should be just a replication network. That will end up with the cluster network state of cluster only. And then if you have a network that you're ignoring for some reason, maybe it's an iSCSI network, a dedicated backup network, or a management NIC, that's going to turn off the cluster use for that network, period. So we won't use it for heartbeating. We won't do anything with it. So here's what that looks like. You can see here, this one on the bottom is set to ignore, gives it a cluster use state of none. Again, that turns it off for all things cluster, all things exchange. And then you have the two public networks, and you have one here I created that was just between the nodes that's set to cluster only. Questions? Good? Excellent. All right, quorum. The concepts of cluster quorum. I have this conversation all the time. I'm really surprised of today the amount of confusion that is still out there about quorum and what quorum actually means across a cluster. So quorum has not changed. The equation is always V divided by 2 plus 1, where V is the total number of votes in a given cluster. Right? So a 6-node cluster, for example, file share witness has how many votes? 7, right? A 5-node cluster has how many votes? 5, right? So that's where we get the V from, making sure that we include the file share witness if we're actually in an even number of nodes. A DAG must always have quorum in order to function. Okay? If it does not have quorum, it will not function correctly. Now, in Windows 2008 R2, administrators used to have to, if they needed to keep redundancy in like a primary data center, inflate the vote count by adding additional nodes. There was no way for you to, for example, tolerate a WAN failure in an evenly distributed cluster and then still be able to tolerate a failure of another resource in the primary data center that you were working in, because you just could not have quorum in that situation. So you would actually install additional nodes in the primary data center in order to inflate that. Now, in Windows 2008 R2, they were kind of nice to us, the cluster guys were, and they gave us a hotfix. And if you installed this hotfix, you could actually go in and adjust node weights. The problem was it's not very popular, and Exchange doesn't work well with it because of the way we try to maintain, for example, the file share witness state. So really, that didn't do a whole lot of good for us. And we'll talk about where that's led us here in a few slides in 2012 and in 2012 R2. So simply put, right, I'm kind of a picture kind of person. So if I lose a link here you can see I've got redundant links between my nodes. For complexity, I could just get rid of that one, period. But anyway, I've got these redundant links. If something goes down, I'm really not in a problem right now from a cluster standpoint. It's not until this link goes down that I actually have a problem. Right? And this is where simple math kicks in. Okay, so I've got 5 total votes. If I divide it by 2, I get 2.5. I drop the 0.5. I add, I get 3. Who wins? A wins, right? And when A wins, those nodes will go down in a lost quorum condition, and our databases will move to the other side. That animation took like half a day. So, thank you. right? So again, this is simple math. And again, you kind of see the conundrum we run into here. In this situation, I can't lose anything else over here. This cluster's stuck with 3 votes. If I lose another node, if I've got to do any kind of maintenance or something like that, I'm stuck, I'm done, right? The entire solution's going to go down. It doesn't get much better with the file share witness, right? A lot of people tend to apply some kind of magic to the file share witness that doesn't necessarily exist there. The same things apply, right? If this link goes down, I do not have a problem. If that link goes down, I do. And again, I've got 7 total votes, 3 nodes plus a file share witness, so the side with 4 is going to win. Those nodes will go down, and those databases will move over. That was the other half of my day. So, again, you end up with here the same situation you ran into here before. If I lose the file share witness, I'm done. If I lose a node, I'm done, right? And this also effectively prevented the concept, especially in 2010 when it comes to namespace designing, of the active-active DAG, right? Clients were most likely bounded in this model. So if you had people that connected over here for mail in this solution, they were pretty unhappy if the WAN went down because their databases are over here and they couldn't get to them. Now, Windows 2012 was the first effort at starting to address some of these things. And it actually was carried forward in Windows 2012 R2 with further enhancements when we introduced the concept of dynamic quorum, right? The thing to remember about dynamic quorum is it does not fix all scenarios. It does not fix everything, right? What dynamic quorum is really saying is that as membership in the cluster changes, as nodes leave, either as the result of failure or because somebody shut them down, we're going to dynamically change the vote count in response to that. And when that node comes back up, that node will get its vote back, and the count will go back up again. This allows us to sustain multiple, and I put sequential here, and it was actually, who in the room knows Boris? Boris Lutavsky. Has anybody ever read his blogs? Boris is a mathematician, so Boris took a look at this and he's like, well, dynamic quorum doesn't work unless every failure is sequential. That's not necessarily true. You can lose groups of nodes and still have dynamic quorum function. It's not like they have to topple over one at a time. So although we publish sequential here, that may not be the best word in all cases to use to describe this. But with dynamic quorum, sir, that is correct. Right. Hence, as Greg has led me so eloquently into, the rules of dynamic quorum. Right? So, a node or a subset of nodes leaves the cluster, either due to shutdown or failure. The first thing that has to happen is there must be enough nodes remaining to have quorum of the original count. So if there was an 8-node cluster and you lost 4 nodes simultaneously, you had to have 5 votes remaining. In other words, the cluster had to be able to reform with the 5 remaining votes in order for dynamic quorum to kick in. If you were to lose 6 nodes simultaneously, this wouldn't matter. Dynamic quorum cannot kick in at that point because you lost more nodes at one time than was the original quorum count to begin with at the time nodes started going down. Now, once we continue to maintain quorum of the original count, that is when we adjust the number of votes within the cluster down to what is left. And again, that will continue as loss occurs as long as rule number 1 is met, that the remaining set of nodes has quorum. So, what's this look like? So here we got our 3-3 split. I lose my link for some reason. My quorum count was 7. So those 3 nodes will drop because I have quorum over here between those 3 nodes and the file share witness. At this time, since I had quorum left over of the original count, we adjust to 4. Now if I lose another node, I still have quorum of the new count. I adjust to 3. I still have quorum of the new count. I adjust to 2, and I'm able to get down to just 1 node. So what you can see here is here you had a group failure, and then here you had some form of sequential failure. Now, had you lost 2 or 3 of these at one time, that would not have been the case, right? So again, dynamic quorum kicked in here and helped us maintain the solution up and running, even in the face of loss, without needlessly inflating the vote count. Now, I kind of said this before, dynamic quorum does not fix everything in all failure scenarios. It is not the end-all, be-all here, right? It dramatically increases the reliability in the face of multiple failures. Let's take a look at a scenario where it does not necessarily help. So I, for some reason, lost node A over here, or node B over here in data center A. So my dynamic quorum count is 3. Now, what I have here is I've got a 3-node solution that now has an even quorum count with no file share witness, right? None is provisioned. It can't be utilized. So the cluster says, well, I can't give both of them a vote, because if I give both of them a vote, well, if I lose the WAN, what would happen? They'd both have a vote count of 1. So the cluster service says, let's pick one, and we're just going to go ahead and knock its vote down to 0. Right? So we picked the lowest node ID in this case, node 1, probably the first node installed, and we gave it a vote count of 0. So what happens when the WAN link goes down? What happens when I sever that link? Who wins? B, right? So in this case, everything would shift over to B when B might not actually be the primary data center that's serving those bounded clients. So this is a case where dynamic quorum did not necessarily fix something for me in the face of me doing some form of maintenance. So, does it change with the file share witness? Right? So, I now have, and that lock, by the way, should not be there. But now I've lost this node over here. So my dynamic quorum count has changed to 4. So what happens if I lose the WAN in this scenario? What? Nope, it's not split brain. If I lose the WAN in this scenario, everything goes down. Why? Because I've got 2 votes over here, not a clear majority. I have 2 votes over here, not a clear majority. In the face of no clear majority, the cluster service just terminates. Right? So again, a situation where dynamic quorum, just by itself, does not necessarily fix the problems that I need it to fix. And this was actually one that came up here. This slide I made after actually experiencing this in a customer scenario where that's exactly what they were doing. They were maintaining a node over here, and they lost their WAN in the middle of maintenance, and everything just went down. So, Windows 2012 gives us dynamic quorum, right? Windows 2012 R2 takes us one step further and says, I'm not only going to give you dynamic quorum, I'm also going to give you dynamic witness, right? And what dynamic witness says is that if I started out with an even number of nodes and I configured the file share witness, and the witness in the vote count becomes odd, then I deprecate the vote of the witness. It's not necessary to actually include the witness's vote in the solution. I will also deprecate the vote of the witness if the witness is found to be in an offline or failed state. So what we can see here, I've got 4 nodes that are up, and if I'm looking here in the cluster registry, this is the quorum resource right here, or the quorum hive, where it contains the information about the file share witness. You can see that there's a weight assigned here of 1 to the witness. So if I take a node and I shut it down, so in this case I took node 1 and I got rid of it, you'll see here that the file share witness is showing offline and its vote is 0. Because there's no reason to give the file share witness a vote in an odd number of nodes. So that takes off that one scenario that we looked at where you ended up with the split. Now, that might still affect the way your clients connect, because again, in that maintenance scenario, we're preferring data center B over A, but you won't end up in a situation where everything goes offline. So, again, I take the witness offline, I've got a vote that's removed, and you can see here that if this goes down, this side's going to win. Right? So again, the ability to remove the vote from a node and remove the vote from the witness at the same time. Now again, by default, if I remove the vote from the witness for some reason, in that case I took the witness offline, so we removed a vote from a node to make the vote count odd, not even. We do that based on the lowest node ID. Now the problem with doing this based on the lowest node ID is that where do you think the lowest node ID actually exists? In your primary data center, right? It's usually the first server you installed, and the first server you installed is in the primary data center. We do give you the ability to adjust this with the lowest quorum priority node ID property of the cluster. When you set that, for example, in this case, you can see here I'm setting it to node ID 4. If I go in and I take the witness offline for some reason, it removes the vote from node 4 instead of node 1. Right? Now, in practicality, do people go and set this? Not really. Did it work well for my demonstration? Yes. To kind of eloquate the point of how dynamic witness actually kicks in here. Questions? Go back? Good? Excellent. Any other questions? Yes. Starts with, wait, does it? Yes. Node ID starts with 0. No, it starts with 1. No, it's 1, 2, 3, 4. I think it starts with 1, not 0. I have to go back and look there to make sure, but I'm pretty sure it's 1. You got Abrams shaking his head, yes, it's 1. So he already has a T-shirt, so he's not going to get one. Any other questions? Yes?
How does that affect having the file share witness in the Azure cloud? Is there any...
Oh, man, check this out. There's a whole section on Azure integration, right? So, all right, here we go. Woo! Thank you. I appreciate that. All right, so we talked about hosting the file share witness. Obviously, you've heard a lot about Azure here in the Exchange space with our announcement that we're going to support it in Azure, right? So here we go. We now have the Azure file share witness, right? So what is this? It is this hugely special, complicated server. No, it's simply a file server, nothing more, that is placed in Azure, okay? Now, there's some requirements that come with this, and some of the requirements that come with it is you must have domain controllers that are replicated from your on-premise environment into Azure. They must also serve as your DNS servers so that there's full name resolution between Azure and your on-premises environment. You have to be able to support multi-site VPN connectivity. Okay, so you're going to have devices that are supported by Azure for VPN connectivity, one endpoint in each of the physical sites that you want to support. ExpressRoute is currently not supported. So for those of you that are already on the ExpressRoute bus with Azure, you're really not able to do this if you wanted to because you can't get the 2 point-to-points that you need as of today. Now, probably the biggest point here, and to your question about how does this change things, your client model really needs to be effectively unbounded, right? So in Ross's presentation on the preferred architecture, he kind of talked about the concepts of global load balancing and that your client really needs to come in, hit the load balancer, and be able to connect to either of the data centers. Really, that's the only way to make this effective, right? Especially with Exchange 2013 and even moving into Exchange 2016, you need to have that. As far as everything else, nothing really changes. The only thing that has changed is where the file share witness is actually at. So you end up with this solution right here. The one thing I will also say is that if you're concerned with where your databases are mounted, you need to be concerned as to where the cluster core resources group is owned. So within every cluster, there is a cluster group. Within that cluster group typically is a name and IP address if you choose to use an admin access point. The owner of that group gets the first shot at locking the file share witness, right? So in this case, if we were to lose this connection, who wins? B. B wins because one of the nodes in B owns the cluster core resource group, and it gets the first shot at locking the witness. And that's where our databases are going to go. You can see I did not spend half a day on that animation. Right. But anyway, you can see here that again, so the reason I point this out, we had a lot of customers who were like, I want automatic resiliency. For example, in Exchange 2010. They were in the bounded model. So they're not paying attention to where their cluster core resources are owned. Their WAN goes down for some reason, and now their databases are running in their DR data center, and their clients are happily sitting in their office over here, unable to use it. Right? Because the person who owns, or the node that owns the cluster core resources gets the first shot at locking the witness. All the other nodes, by the way, sleep for 6 seconds. By default, that's known as the arbitration delay for the witness. But again, if you meet the core criteria, there's no reason not to host your file share witness in Azure and use Azure as your third site. It works very well. It also does not alter any of the site resilient processes. So for example, if data center A was legitimately a crater in the ground, your databases would move over like they're supposed to, and you could still go in, run stop database availability group, run restore DAG. The only guidance that I've actually changed there is when you run restore DAG, you specify the same witness as the alternate witness too. There's no reason to change the witness to one that's located here for some reason. But again, nothing's really changed. So other than placing it in Azure and getting yourself the automaticity with the site resiliency, it's really just about the same. Yes?
So how would the companies who are hesitant to put the domain controllers in Azure?
Yes. Well, I didn't hear a question, though. I'm sorry.
Why would we need to put a domain controller in Azure?
Great question, right? All right, so the file share witness here is secured. It's secured by a machine account. There has to be an authentication source. So if I were to not have a domain controller here, I would not necessarily have access to an authentication source. Not to mention, if Azure becomes an island for some reason, you lose these connections and your WAN goes down, it'd be nice to be able to auth to this box without having to use cached credentials that you probably don't remember anymore. All right? So that's why. Basically, there has to be an auth source present. That's one of the requirements. Plus, the other nice thing is generally, I mean, how many people are not using AD integrated DNS for some reason? Okay, so definitely the minority in the room. The other reason was in the majority of cases where this is feasible, deploying a domain controller comes with AD integrated DNS, which gives us the name resolution that's required. Right? If you're using a non-AD integrated DNS solution, you're responsible for deploying that DNS server into Azure. Questions? All right, moving on through here. Yo! Well, you could, right? And you know what? Why don't we do, if you want to explore that topic, I'll be more than happy to talk to you afterwards. It would just lead us down to a tangent that I'm not ready to go on right now. The question was, could I force quorum? The answer is yes, but no. So it's unfortunately, most of the people that force quorum do it incorrectly, and then they end up talking to us for hours longer than they would have otherwise. Huh? Great question. How do you ensure that the cluster core resources are in the desired location? Answer, you don't. Right? There is no effective method that is supported to prevent the arbitration of the cluster core resources between site. Other than you, for example, if you were in a bounded model and you were concerned, you would literally most likely end up scripting a move to run to a node in the primary site, even if there was no reason to move it. Because it's just not something that you look at. In the unbounded model, we would tell you who cares. You really should not be that hung up on whether or not a database is over here or over there. The question is the database online and is it servicing clients? Right, that's really what it kind of gets down to. But the answer is please do not try to get creative. Please don't remove preferred owner. Please don't remove IP addresses. Please don't try to change who can own resources. Eventually that will lead to you having a failure that you should not have had otherwise. I saw a hand. Absolutely, right? But why would I? I mean, I have quorum over here. I could block those nodes from activation. I mean, that's perfectly theoretically possible. But now I just have a cluster that has quorum and databases that were dismounted anyway, right? The only reason that might be helpful is if you're going to try to get creative with force quorum, which, again, I don't even want to get down that path right now. That is correct. Questions? All right, administrative access points. So for those of you that subscribe to my blog, I recently published a blog post called Exchange 2013, My DAGs Gone Commando, where I talk about the administrative access point list DAG, right? This here is our preferred architecture for Windows 2012 R2 with Exchange 2013, and will be the preferred architecture moving forward in Exchange 2016. Now, there's some things that come up here, and I try to want it to kind of call them out, but there's some things that come up here as you're considering deploying this, And that is that, number one, there is no name and no IP address associated with the access point. Now, I find that helpful because it reduces complexity. Some of my Exchange admins find it helpful because they don't have to deal with other people, right? I don't have to deal with the AD guys. I don't have to deal with the networking guys. I can just set up my cluster and live by myself, right? So some people find that that reduces complexity. But some of the things from the support standpoint people have to get used to, there's no failover cluster manager GUI, right? So if you wanted to interrogate for some reason what the cluster networks look like, you're not going to be able to open up the GUI and actually see them. You're going to have to get familiar with the Windows PowerShell commandlets, okay? And sometimes it causes third-party compatibility issues. Does anybody know who the prime candidate for that is? Backups, right? Almost universally, backup vendors, for some reason, have decided that even though we've told everybody from day one we have no dependencies in Exchange on the network name and IP address and the cluster core resources, they decided to make one, right? And what we find is we find that the backup vendors, for some reason, connect to the DAG name, do some enumeration of node states, and then perform some backup. And you can see that if the DAG name's offline for some reason or something along that nature, your backups will fail. Right? So, you either have to decide, what you're going to do with that type of integration if you run into this problem, if you want to adopt this. So, as was pointed out to me on my blog by somebody in the room, this can cause a lot of issues, especially with the third-party integration. So you've kind of got to weigh the preferred architecture versus what it is you're trying to do. Yes? You know what? The answer to that question will be discussed tomorrow in Abram and I's presentation. So if you want to know, come to Abram and I's presentation tomorrow. You can. The answer is yes. There's creative ways around that. So, the part that I was promised to talk about, very exciting, right? What is Windows Server 10 going to bring us with future versions of Exchange? It's a fantastic question. I didn't write my own abstract for this presentation. Somebody else wrote it for me. So since I promised I'd talk about Windows 10, I put it in here. There are some things that we are considering supporting with Windows 10. And there's kind of two things that come up here as being interesting. The first is Windows Server 10 will be the first version of the cluster service that will support mixed node states. So it will be possible to have a Windows 2012 R2 cluster and to join Windows Server 10 nodes into that same cluster. Additionally, the cluster team has decided to implement a native file share witness resource, if you want to think about it that way, that is based on Azure Cloud or Azure Blob Storage, and it's called the Cloud Witness. So that's actually being built directly into Windows 10. So this is what the Cloud Witness looks like. It has a pretty little cloud next to it. Really what you're doing is you're going into the cluster configuration and you're actually providing the URL to your blob storage and the private key or the access token key to that blob storage as part of the cluster configuration, and then we're using that for a witness. This down here is just a sample that shows you today. If you download the Win 10 Tech Preview, you can actually join that to an existing 2012 R2 cluster. Now, what's our potential in Exchange, right? What can we actually do with this? Well, when we talk about this being able to mix cluster versions, it might actually be the first time we can support rolling upgrades, right? So today, if you're like a Windows 2008 R2 shop or a Windows 2012 shop with Exchange 2013, and you decide you want to adopt Windows 2012 R2, your only option is to build a brand new DAG, migrate all your mailboxes, and that becomes painful in some instances. It also becomes long. But we would like you to be on the latest operating system, especially one that's being serviced and currently maintained. So this is an opportunity where we can start re-architecting some portions of Exchange to potentially support this. So what we're looking at is that this is not an in-place upgrade. So this does not mean you're going to take your existing DAG node, you're going to stick your Windows 10 Server CD in, and you're going to click Upgrade. That's not what we're talking about here. What we're talking about here is you build a brand new Windows 10 server, you go ahead and you install Exchange on it, and you join that to your existing DAG, and you replicate your databases over. Okay? Now, the biggest thing that architecturally, the work here is actually pretty steep to make this feasible, because we have to deal with the locale issues of changing operating system versions and database indices and things along that nature. So there's still a lot of work to be done there in order to make this work, and one of the reasons it's also a little bit more time-consuming is that you can't really do the code work and validate it till you have a pre-release version of Windows 10 that's close to RTM. So, we've got to wait for the Win 10 server guys to get us something that we can actually code against to actually even begin to test something like this in order to bring it to market. For the cloud witness, we would need to, yes?
Can you be more precise about what you mean that we upgraded the database drive? You're not saying that you're creaming or moving the database drive. You're just saying the OS drive is being reformatted in Windows OS. Changes reloaded on that. And you're saying that you're reseeding all the database.
Without any specifics, my understanding is it's burn it, reseed it, and bring it all back. It is not reuse the existing storage or anything along that nature. You're bringing brand new servers, brand new storage, and reseeding. And again, with the Cloud Witness, there's some talk about whether or not we need to extend the schema in order to support the Azure information that you'd need in order to actually just create that Cloud Witness for you as an alternative to hosting a file share in the third site. Yo! Yes? I'm not willing to comment on that today. Well, and that's why I said this is most likely going to be a slash and burn. You're most likely going to bring new hardware in as a part of this. You should be fine with that. So from a cluster standpoint, from a cluster standpoint where no shared storage is involved, there should be no issues whatsoever hosting different controllers. What has to be the same, though, your drive layout has to be the same, right? So if you're currently, for example, if you're currently deploying on 2 terabyte spindles and you can only have one database per spindle, and now you're going to buy servers with 8 terabyte spindles, you're going to run into some issues there with your database layouts. Are you, there's an assertion that there's guidance on the Exchange side that everything must be the same. I'm not aware of it either.
I actually know
Huh?
clusters. I actually know of clusters where
I was going to say, I'm the exact opposite. I've got clusters that are mixed hardware.
you have DAGs on one side and SANs on the other side.
Yeah. Yeah, I don't see any reason why you shouldn't, but I mean, that's me. Let me plow through this here. I've got 6 minutes left and people are already running away. So some things here to be successful, right? Maintenance. Please, please, please be looking at your drivers and firmware, right? I put 2 quotes. Both of these quotes came just last week out of 2 cases I worked. Why do I need to upgrade my drivers? Nothing has changed. That's my favorite line in the world, right? You've got 5-year-old NIC card drivers. Nothing has changed. All respect to the guys at Broadcom and Intel, but I'm pretty sure they did not anticipate the changes we're going to make to TCP/IP.sys every time you download a fix that contains TCP/IP.sys, right? And the other one, these 2 servers are identical and the other one works just fine. That's my other favorite line that just came up this week, when we can clearly show that they clearly do not work just fine together, and the other one's probably not as healthy as you thought it was to begin with. So please be taking some time to maintain your servers, maintain your drivers and your firmware. I did want to give you the Windows 2012 R2 recommended hot fixes. For those of you that want a blog post to follow, this is what we update in the KB regarding recommended fixes. Now, the only caution I'll give you here is that this covers the cluster services use with a whole array of products. So it could be a specific Hyper-V fix. It could be a specific file share fix. So you kind of have to weed through them and kind of determine what is relevant to your particular scenario with the DAG. For those of you that are doing site resilient scenarios, test, test, and test. We'll talk a little bit more about that tomorrow in Abram and R's presentation. And the preferred architecture, please take a look at it. Again, it's not designed for all situations. It is designed for all situations. As I told somebody this week as we were having a spirited debate on my blog, it is not meant to cherry pick the things you like and ignore the rest. It is meant to adopt it as it is. So thank you very much. I appreciate you coming. I'm going to put a real quick shameless plug in here. I would really appreciate if you fill out your speaker evaluations. Coming from support, those are really important to my boss to justify my time here. So if you don't mind, I would appreciate it. Thank you.